Hello everyone, welcome to Praxam, and this is Jyotirath from Praxam, and in this brief tutorial I'm going to show you how to solve this given system of linear equations using solver add-in in MS Excel. But before that, before beginning, you need to make sure that the solver add-in is enabled in your system under the data tab. If not, you are going to go to this file tab, and in this you have something called as more, and in more you have options, and these options you're going to go to this add-ins, and in the end you will find manage Excel add-ins. So click on this go, and in my case, since it's already enabled, so the checkbox has already been ticked. In your case, if not, you're going to click on this checkbox and click on OK. Once this is done, you will find the solver add-in enabled under the data tab. Now talking about the first step. The first step that we need to do is check for the consistency of the system. So for that, if the system is consistent, we will find that the determinant value of the coefficient matrix of the entire system of equations is non-zero, and hence the system is consistent and solution exists. If not, then obviously the system is inconsistent and the solution does not exist. So the first step is checking for the consistency of the system. So let me just write down the coefficient values of each of these equations one by one. For the first equation, we have the coefficient values as 3, minus 2 and plus 3, and for the second equation I have the coefficient values as 2, 1 and minus 1, and for the third I have 4 minus 3, 4 minus 3 and plus 2. Now in order to find out the determinant value, we are going to make use of the function called as the mdeterm. So I'm going to write equal to mdeterm. So once I write that, the mdeterm function arrives and it says that it returns the matrix determinant of an array. So I'm going to click on this and I'm going to provide the array. So this is my entire array. So as you can see, the mdeterm function returns the value minus 70. So the determinant value is clearly non-zero and the system of linear equations is consistent. So now let us first write down the variables and their values. Variables and their values. So in this case, the variables are x, y and z. And let us, for the timing, initially assume the values of x, y and z as 1, 1 and 1 respectively. Now the first thing that we need to do before using the solver add-in is check for the subjective constants. Now in order to solve these three equations, what is the subjective constant? The subjective constant is that my LHS of each of these equations must be equal to the RHS. So the next thing is subjective constants. So here I will have these LHS and RHS. Note that the LHS of each of these equations is nothing but the sum of the product of these variable values and the coefficient values. So I'm going to make use, for the first equation, in order to find out the LHS value, I'm going to make use of the function called as the sum product. So equal to sum product. So what is my first array? The first array is this one. And my second array is this one. So this is the left hand side value, and for the RHS value I have already have it as 8, and similarly for the next two equations I am going to use the same process, sum product, and the next array, which is my variable array, and the RHS value is 1 again for the third equation once again. And the RHS value is 4. So once this is done, I am going to open this solver add-in. Now note that the first thing is the set objective, since we are not optimizing any function here, so the set objective is going to be empty. And the next step is this, by changing the variable cells. So this is the first parameter that I need, and in this case I want to change these values. So this will be my variable cells range. So I have selected this one, and the subjective constants. This is where I will be adding the constants one by one. So the first constant I will be adding, I will click on this add option, and the first cell reference, I want this to be equal to, so I will click on this equal to option, and the constant is this one. Once this is done, I will click on add. Now we'll add the second constant. Second constant is this, once again equal to RHS, which is my this one. I will click on add, and for the third one, this equal to, I will click on this. Once this is done, I will not click on this add, I will click on this OK, since this is the last constant, and once this is done, I will click on OK. And as you can see, the three constants are there. Now I will check the solving method. The solving method has been selected as simplex LP, and clearly it says that select the simplex LP engine for linear solver problems, and it is already been selected, so the solver method is appropriate, and I will click on this solve. So instantly solver found a problem, and as for the report part, I will click on this answer and click on OK. So as you can see, it was previously 1, 1 and 1, and the solution has now changed to 1, 2 and 3. This is the solution. This is the solution to this system of equations. Now let's have a quick look at the report that has been generated. Now in the report that has been generated, it says the original value, which was my initial value for the variables x, y, and z as 1, 1 and 1. And the final value is there 1, 2 and 3, and in this very simple way you can solve this system of linear equations using solver add-in in Excel. I hope this thing helps, and if you find this video helpful, don't forget to share this video along with your friends. And yeah guys, that's it for now. Thank you guys for watching.